Okay, so we're going to use sine, cosine, and tan of obtuse angles. So we're going to find the measure of the obtuse angle using properties of supplementary angle. We talked about supplementary angles before, and we talked about how supplementary angles, they add to 180. And we talked about, depends on what quadrant it is in, if it's an acute angle, so it's in quadrant 1. How sine, cosine, and tan are all positive. And if it's an obtuse angle, right? Sine is positive, but then cosine and tan are negative. Do you guys remember that? Okay. So an acute angle is less than, just to recap, is less than. An obtuse angle is between 90 and 80. And supplementary angles are two angles whose sum is 180 degrees. I've already kind of went over the quadrant and the Cartesian plane with you, but I'm gonna revisit. Okay? So this is the x and y Cartesian plane. So this is what we're used to, but now we're gonna use it for angles. Okay? We talked about how we have different quadrants. We have quadrant 1, quadrant 2, 3, and 4. Right? We talked about how in our course we're gonna only use quadrant 1 and 2. Right? And then we start measuring. When you're measuring an angle, you're measuring it from the x-axis counterclockwise. Okay? So the angles would start with 0 degrees on the x. And we said the x and the y make a 90 degrees. So anything that falls on the y is a 90 degree with the x. And then anything that falls back here is going to be 180 degrees. Right? So if you have an acute angle, what quadrant would it fall in? 2. It would fall in 1. Right? If you have an obtuse angle, what quadrant would it fall in? 2. So this is where the acute angles are, and this is where the obtuse angles are. Are we okay with this so far? No. So, do you remember how we said SOHCAHTOA and then opposite over hypotenuse and adjacent over hypotenuse and opposite over adjacent and all of this? We're going to define SOHCAHTOA now again by using the coordinates of a point. Okay? Yes, it's going to seem weird right now, but you're going to see what I'm talking about. So, trigonometric triangle can be defined using a point pxy on the coordinate grid. If point pxy is in quadrant 1, then the angle A is an acute angle. So let's try this. So this is my Cartesian plane. So this is x, this is y. And let's say I have a point here, which that point is this point. Okay? So this is my point right here, which is x, y. Okay? I just put a point in the first quadrant. Okay? Now if I want to make a triangle, I can make a triangle, right? I can simply do this. Go from the origin to that point, right? And then down. I always have to make it down with the x axis. Okay? So you see that my triangle is this triangle. Yeah? Are we okay with the triangle? Where would my angle be? The angle that I would measure.
The point?
Remember that angle is measured from the x-axis. So this is where your angle is. Okay? So this is where the angle is. Okay? So from the x-axis to the terminal arc. So this way. Okay? Now, I'm I'm gonna call this angle theta because we like to use theta, right? Okay. Now, if you're looking right here, this one, what does this represent? Y or X?
Y.
This represents Y, right? The Y is going up. The Y is vertical, right? So this right here represents Y. How about this right here? X. Right? And then this here, we're going to call it R because that forms, if I actually want to draw a circle with the center right here. So if I'm going to actually draw a circle, I can't draw a circle here. I'm going to have to, it won't work. No, it's not going to work. Okay, so if I draw a circle with my origin to be at the 0, 0, and I actually do a circle, this is going to be my radius. Okay, if I'm gonna have to make it into where that point falls on the circle. Okay, this is going to be my radius. So that's why we call it R. Okay, so let me just go back here. So I have my origin here, right? I have my point on the circle. This is the x-axis. Pretend that this is. Let's see. Okay. This is the y-axis, right? If I draw a triangle from this point to this point and then going down, this is the radius of the circle, right?
Yes.
So that's why we call it R. Okay? Can I erase this now?
Yes.
How do you delete this circle? Okay. Now, so this is what I have. I have a triangle. I have an angle theta. I have x, y, and r. Okay? What would sine theta be? What's sine an angle in a triangle triangle? What's the formula?
Opposite of y hypotenuse.
Okay, so what's the letter for opposite?
Y.
R.
And what's the letter for hypotenuse?
R.
So it's going to be opposite is y, and hypotenuse is r, right? So sine theta is y over r. How about cosine theta? What's the formula? Adjacent over hypotenuse. So what's the adjacent here? X. What's the hypotenuse? So it's x over r. How about tan? Opposite over adjacent, so that's y over. Okay, so in a Cartesian plane, we start using x, y, and r. Okay, and then that's why it is. Thank you. And that's why you would see that sine theta is y over r is because of the formula, right? It's not like they didn't just decide to call it y over r. There is a reason for it, and it's because y is the opposite of the angle, and r is the hypotenuse, right? So they're still using the same formula, they're just calling it differently. Okay? All right. Now, this is kind of going to help us define why cosine and tan are negative in the second quadrant. Okay? You see here, y is positive, right? Because I'm in the positive quadrant, right? Cosine is positive because I'm in the positive. Sorry, x is positive because I'm in the positive quadrant, right? So that's why all of these are positive. Think about what would this point be? What would this point be? What would this point be?
What would it be?
Yeah.
Oh,
4, 3,
4,
4, 3, 4, 3. 1, 2, 3.
Okay.
4, 3. Right?
Okay.
So I can solve for r easily using the Pythagorean theorem. Yeah? Yeah?
Yes.
Okay. So if I know that r is going to be positive for sure, and I can solve for it easily. It's going to be 5, by the way. 4 squared is 16. 16 plus 9 is 25. Yep. So it's going to be 5. So this is positive, and r is positive. Right? So if I'm going to take this is x, and this is y. If I'm going to find sine theta is going to be y, which is 3 over 5. That's positive. Cosine theta is going to be 4 over 5. Positive. Tan theta is going to be 3 over 4. Positive. So all of them are positive. Do you agree?
Yes.
Yes or no?
Yes.
Okay. This is what we were learning the other day. They're all positive in the first quadrant. Okay? Let's look if it is in the second quadrant. What happens? If point P is in quadrant 2, then angle A is an obtuse angle. Using SOHCAHTOA to define each trig ratio for its supplementary acute angle. So let's say I have this. Let's say I have a point which is, let's make it -4 and 3. Okay? So I have a point in this quadrant right here. And I'm going to make a triangle. Which way do I make the triangle? Going down. Because always it has to go with the x. Okay? Where is my original angle? Original angle. Where's my angle? From where to where?
From the point of origin to the top.
It's the angle that's hitting the x-axis.
So right here or right here? Where do I measure from?
Oh,
I measure from the x-axis over there. What kind of angle is this? Obtuse. Good. Now, this angle right here, which I'm going to call it theta, that little angle right here, what can I call this angle?
what can you call it?
Yes. If this is my obtuse angle, that's going to be my supplementary acute angle, right? Because this and my obtuse angle, they're going to make 180, right? So that theta is my supplementary acute angle, right? So theta is supplementary acute angle. Good. Now, in that triangle, what's the value of x?
X is -4.
-4, right? So x is -4, and I'm going to call it -x. Right? In this case, it's -4, but to make it general, it's going to be -x. Right? Because it's going to be whatever. In this case, it's 4, but it could be -5, could be -2, could be -6, it could be whatever. Right? It's a -x. What's the value of y?
Positive.
+3, right? So it's going to be just 1, right? And what do we call this? The radius, right? It's r. Yes, it is used to be the hypotenuse. Now it's called r. Okay, so what I want you to do right now, using x y and r, or negative x, y, and r, I want you to find sine theta, cosine theta,